everyone, my name is Vaishnavi Moli. I am currently pursuing BTech in the Department of Computer Science Engineering from Sri Venkateswara College of Engineering, Kadapa. This presentation is all about home automation based on IoT. It is a part of IoT internship at EMERTXE Information Technologies. These are the contents we used in this project. Topics learned during internship: C programming, keywords, basic data types, operators, conditional constructs, arrays, pointer functions, storage classes. We also learned C++ programming, basic concepts, that is OOP concepts. And also we learned introduction to IoT, introduction to embedded systems and peripherals. Peripherals required for the project: LDR sensor, temperature system, serial tag. What is an IoT? IoT is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. This is IoT architecture. What is embedded systems? Embedded system is combination of hardware and software which is intended to do a specific task. This is embedded system architecture. Project requirements: control garden lights on basis of sunlight intensity, temperature system control, water tank control. Requirements we had in hardware and software. Hardware requirements: Arduino Uno, Ethernet shield, temperature system, LCD, LDR, LED. And software requirements are Arduino IDE, PiximLab, Virtual Serial Portkit, Blink IoT app. Arduino Uno is a open source microcontroller. It is based on Atmega 328P. This is Arduino board. Ethernet shield, that is ETHW5500. It is a hardware TCP or IP embedded Ethernet controller that provides internet connection to embedded system. This is survey of Ethernet shield. Temperature sensor, that is LM35. LCD, liquid crystal display. It is used to display alphanumeric and symbols. LDR sensor, light dependent resistance, is a component that has a resistance that changes with the light intensity that falls upon it. These are the output screenshot we had when we load hex file. This is the screenshot when LDR is high, so LED is on, and LDR is low, so LED is off. This is when cooler is on and when cooler is off. This is when heater is on and when heater is off. This is inlet valve is on and when inlet valve is off. This is the picture of when outlet valve is on and when outlet valve is off. These are the screenshots of mobile. We in Blink app, here we can see notifications of temperature and water level tank. Water level of tank. Notification of heater temperature and Heater will automatically turn off when temperature rises above 35. Notification of water level. Water tank is full. Inlet valve will automatically turn off. Water volume level. This is the conclusion, and finally, thank you. Now I am going to explain code for this home automation. First we are including all the header files and libraries into it. Then we are writing authentication code which is of Blink Cloud. Then we will mention different functions and their definitions into it. So this cooler vpin, here it is placed. This cooler vpin function defines, it gives the control to control the cooler by clicking on and off in the Blink application. Next, heater vpin. When it comes to heater vpin, it also takes input and display. When the heater is on, it will show on, and when it is off, it will show off. Next, inlet vpin. The inlet pin will display the inlet flow of water tank. So it will again enable the inlet, and it will show that the cursor on LCD whether the flow is on or off, and it will take parameter and it will read the values from the Blink app. Next, outlet vpin. In outlet vpin, it shows whether the flow is on or off on the LCD screen, and these methods are called enable and disable outlet of serial tank. Next, update temperature reading. It shows the temperature and water level in the Blink application. And next, handle temperature. It shows that if temperature is greater than 35, it will show automatically turn off the heater, and a notification will be appeared on the Blink application. Next, handle tank. In handle tank, if water is less than 2000, the inlet valve is on, and if it is reaches 3000, and the inlet valve is off. Next, Blink visual write is used to display notification on the Blink. Here, inlet vpin Blink. It is used to display notification of water level on the Blink. Connecting Arduino to the Blink server. Setting cursor to second line to display volume of water. And this is used to control the brightness of garden lights using LDR sensor. And when it comes to LDR.cpp, we are declaring the brightness control method, which means that this method will declare that blinking of LED with the help of LDR. Next, LDR.h. It is the header file where we have declared the macros LDR sensor, and we have given it as a value, and we have also defined the methods. In main.h, here we declared all the macros that we are using in the program. These are the macros. Serial tank.cpp declares that the methods into it. In this value method, it will declare the volume, how much water in the tank. Here is enabling the inlet valve, disabling the inlet valve, enabling outlet valve, disable outlet valve. Next, serial tank.h. It is the header file that will mention all the macros in it, and the method names are declared over here. Next, temperature system.cpp. Temperature.cpp will give us about the methods. Name that cooler control, that means it will give digital write cooler control, which means that the values will be read by the system when the machine is on and off, and it will be passed and declared in the LCD similarly when it comes to temperature. This will convert the temperature into degrees Celsius. This method will be helpful to converting the temperature into degrees Celsius, and it will declare all the methods that is required for the temperature system. Next, temperature system.h. In this temperature system.h, this is the header where we are already declaring the method names and we are declaring all the macros. In this way, we will able to code our system, and once our code is ready, we will compile it. Here we can compile it. It is compiling. It is compiled successfully, and we want to load this code in PiximLab. This is PiximLab. Here we can upload the file. I am already uploaded the file. This is reset button, and we can go simulation part by clicking here. This is simulation part. Here we can see LDR and LED. When LDR, that means resistance, is low, the LED will be off, and when resistance is high, here we can see LED is on. Similarly, when we take tank and cooler, it will display you in Blink application. We can do these things, that is cooler, temperature, and water level tank will be done using mobile application, that is Blink application. Now here we will see in tab 1. When cooler is on, we can see here the cooler is rotating here, and temperature will decrease when cooler is on. When cooler is off and heater is on, we can see here is temperature is increasing. Here temperature is increasing, and also it displays in the CLCD when temperature is increasing, and it will automatically turn off heater when it reaches 35 degrees Celsius. And notification will be seen here when here is notification, temperature is above 35 degrees Celsius, turning off the heater. It automatically turn off the heater. Next we will see water tank in tab 2. In tab 2, when we turn on the inlet valve, we can see here water is flowing into the tank. When it reaches 3000, it automatically turn off the tank. Here also shows tank volume is off because it filled 3000 liters. And we can see here outlet valve. When it is on, water will be flow out of the water tank. You can see here it also decreases water level tank. When it reaches 2000, it automatically switch on the inlet valve. And we will see here notification at water volume is less than 2000, turning on the inlet valve, and also water volume is more than 2000, turning off the inlet valve. So this is the project, and this is CLCD, LED, LDR, temperature system, Ethernet shield. Thank you everyone, and also thank you for EMERTXE Technology for providing this internship